Hi folks, we're going to take a look at number 16 from page 53. So here they give us this piecewise function and they want us to find a and b such that this function is going to be continuous on the interval from -3 to 0. Now I just want to remind you that when we're talking about continuity at these endpoints of -3 and 0, it's assumed that we're talking about um, one-sided continuity. So here from -3, we can only approach it from the right, and 0, we can only approach it from the left. All right, so we're going to use the definition of continuity to be able to solve this problem. And in order to be continuous, limit has to exist at every point, and the limit has to be equal to the function value. Now, if we look at x, that's just a polynomial function. So on its domain, there's no issues. Here, this is a quadratic, no issues with continuity. The only place where we're going to have an issue is where the function changes definition, okay, which is going to be at -2 and at 0. So these are the only 2 points we need to look at. So we're going to start with the limit as x approaches -2, and we're going to approach it from both the left and from the right, okay? And we'll see if, and because we want it to be continuous, these limits have to be equal. So as x approaches 2 from the right, sorry, -2, and I know because I need it to be continuous that these two things have to be equal. So let's find the individual limits. Now here, again, like we said, this is just a continuous function everywhere. So when we're finding this limit, we can just input the number. So -2 is equal to 2. All right. And same thing on the right, even though it's not defined at -2, the limit will exist since this is a quadratic. So I can just input -2 into here. So -2 squared is 4. So I end up with 4a plus b. All right. And so I end up with an equation with two unknowns. So I'm going to need some more information. So the other thing that needs to occur is it needs to be continuous at 0. So same thing here. The limit as x approaches 0 from the left of f at x, okay, has to be equal to, now this is where we have to be careful. This is not defined to the right of 0. So we can't consider the limit as x approaches 0 from the right. But because we want it to be continuous, we need this to be equal to the function value at 0. Okay, so this is the condition we're going to use to deal with the scenario at 0. Okay, because we can only talk about left-handed continuity here. All right, so if we take the limit as x approaches 0 from the left, so again, we're dealing with this function here, so we could just input 0. So a times 0, 0. So plus b is we just have b, and the function value at 0 is equal to 6. So in fact, we already have one of our, we didn't really have to solve a system of equations because the b turns out to just be 6. And so now we can substitute that back into the other condition. So we have 2 is equal to 4a plus 6. And so 4a is equal to 2 minus 6 is -4, and a is equal to -1. Okay, and there we have it. So again, we had to use the fact at -2 that the limit from either side was going to be equal because the limit has to exist. All right, and then at 0, because it's not defined to the right of 0, we use the fact that in order to be continuous, the limit has to be equal to the function value. And from there, we were able to solve for the unknown variables. All right, that's it for this one.